Okay, now just a couple of simple calculations, one of them with some symbols. Multiply 3 by this, add 2 times this, what do we get? Well, it's very simple, and I'll do this kind of quickly. You can verify my numbers and see if I make a mistake, as I often do. These things are live and not premeditated, at least not pre-calculated. I think about them before I do them, but doesn't mean I execute them correctly. Okay, so negative 3 and 2 is negative 1. Negative 9 and 4 is negative 5. 6 and 6 is 12. Now that was easy. Okay, and assuming I did everything correctly, and maybe I did. And if I didn't, you can easily correct it, because you should clearly understand very easily what I did. Just multiplied 3 by every one of these to get these. Multiplied 2 by every one of these numbers to get these numbers, added accordingly. Okay? Now, symbolically, because we need to think in terms of symbols a little bit. C1 times negative 1, 3, 2 is what? It's negative C1, negative 3C1, 2C1. To that we add C2, 2C2, 3C2. And we get negative C1 plus C2, negative 3C1 plus 2C2, and 2C1 plus 3C2. Now, what does all this mean? Okay, well, this is just a vector. It's 3 times as long as this one, and in the same direction. I don't think I have room to draw it. If we go 3 times this far and in the same direction. And then what's the vector 1, 2, 3? Well, that's a vector 1, 2, 3. We could easily draw this. We would have 2 units in the y direction, 1 unit in the x direction, and 3 units in the z direction. So I could sketch, and I'm not going into detail on how I do this. I could sketch this and maybe sketch this vector from here to here. Now this vector looks quite a bit shorter than this one, but it's of the same length because I have the same 3 numbers, except for the signs. And when I add their squares, I'm going to get the same thing. Okay? It looks shorter just because of the angle that we're viewing this coordinate system. The angle from which we're viewing this coordinate system. Okay? So if I took 3 times this, I could draw a box 3 times as big. And then 2 times this, I could draw a box with twice the dimensions of this one. And I could put those 2 vectors together, the head of this one, the head of the second one to the tail of the head of the first one. Let's use the terminology. The terminal point of the first one being the initial point of the second. And I might have a picture that looked something like this. Okay? And my resultant vector would be this one. Okay? Now, if I've done that accurately, this vector would represent this. Now, I didn't have drawn the boxes, and it's a little hard to see. And I violated my title page there, vector spaces. But that's the general idea. Now, with a little practice, it becomes very easy to draw these, and even to draw them quickly. And we do want to be able to do that to some extent. Okay, well, now what does this represent? C1 and C2 can be any numbers. So this represents this here could represent any vector that can be obtained by multiplying this by some number, which will either make it longer or shorter depending whether that number is greater or less than 1, and will also reverse its direction if the number is negative. Well, that's all easy to understand. Whether you understand that right now or not, that's something that's going to be fairly easy to understand. And then we multiply this by some other number, okay? Well, when we do, it turns out that the vector here that we always get is in the plane formed by these two vectors. Okay, that means if you take these two vectors, if they're like this, okay, wherever they are, and whatever their angle, you draw the plane. You imagine placing a piece of thin glass over the two vectors. There's only one way to do that. It's got to be like this. Again, you might not understand that. We'll do a more thorough explanation. But then these two vectors form a plane. And every combination of these vectors is in that plane. So that I'll say for all real numbers, C1 and C2, for all real numbers C1 and C2, the vectors that you get here form a plane in three-dimensional space. Okay? And that plane is an example of a vector space, a subspace of three-dimensional space. I'll talk just a little bit more about that in the next video.